and welcome to Generalizing to the Population. So the idea here is in a statistical study, uh, we can't reach the entire population, so we use a sample, or we take a small sample out of the population. So we pick a sample from the population. Once we have that sample, then we simply study that sample. We don't study the whole population. So then we study the sample. And then we try to take those sample results and generalize them to the population. And in order to do this, we will use probability. So again, remember our good sampling methods were all based on completely random sampling. And so we will take advantage of the random selection to then figure out, use probability to figure out the likelihood of certain events happening. So from here, we will use probability to make essentially educated guesses, which we will call inferences. Or statistical inferences. About the population. So we are going to play around with a quick example. In this example, we have two siblings that are debating over who gets to sit in the front passenger seat of a car. So Grayson has been flipping a coin to see if he or his sister gets to sit in the front seat. And Grayson has won with heads for all 5 of the coin flips that they have done. So his sister is starting to think the coin might be weighted. Does she have good reason to think that the coin could be weighted? So what we're going to do is we're essentially saying, so the results were the 0 out of 5 coin, or sorry, 5 out of 5 or 0 out of 5, depending on how you want to look at it. Flips went in the sister's favor. Or 5 out of 5 were heads. So when we flip a coin, we expect it to be about 50% of the time it'll be heads, about 50% of the time would be tails. Right? So we would expect somewhere around 2 or 3 heads if we're flipping a coin 5 times. So with a fair coin flipped 5 times, we would expect 2 or 3 heads. But again, that's not guaranteed to happen. Each coin toss has a 50-50 chance of coming up heads, and we could have all 5 come up heads possibly. So essentially what we want to know is, if the coin were fair, would these results have been likely? So if the coin were fair, would the results of 5 out of 5 heads be likely? Or is it surprising enough to make us think the coin is weighted? So what we are going to do is we are going to play around with a simulation that is actually straight out of module 11 from Canvas, where we will look at flipping 5 coins at once and see how many heads come up. And we are going to do this over and over and over again and see what results we get flipping a fair coin. So here's our coin flipping. So let's go ahead and just do one set of 5 flips. And this time around we had 2 heads, 1, 2 heads. So we got, we're showing on our histogram that we had 1 result with 2 heads. If we do this again, we now have 2 results with 2 heads, and a result with 3 heads, another with 2, another with 2, another with 3. So we're getting what we would expect usually. There's one where only 1 head came up. There's one with 5 heads and one with 0. And so now I've done this 10 times. I'm going to start skipping. So here's another 10 times, another 10 times, another 10 times. And now we've done this 100 times. So this is with 100 times of flipping 5 coins. We had 4 times we had 0 heads, 10 times with 1 head, 36 times with 2 heads, 29 with 3 heads, 19 with 4 heads, and 2 with 5 heads. So from here, let's go ahead and record these results back in our notes. So I've just drawn the histogram we had. So this was from flipping 5 coins, fair coins, where there's a 50% chance of being heads on each coin flip. Again, here were the results we had. We had 4 times we got 0 heads, 10 we got 1 head, 36 2 heads, 29 3 heads, 19 times we had 4 heads, and 2 times we had 5 heads. So in all, this was 100 tries. And out of those 100 tries, we had 2 times where we got 5 heads. So out of our 100 tries of flipping a coin, or flipping 5 coins, flipping a coin 5 times, a fair coin, 5 times. Only twice do we get 5 heads. So what this tells us is that it's certainly possible for a fair coin to come up 5 heads on 5 coin flips, but it is not very likely. So it is possible for a fair coin to come up heads on all 5 flips. But it is highly unlikely. Only 2 out of 100 times did that happen for us. So what we get from here then is that, I don't remember the name of Grayson. Is that who we were? Okay, sorry for the scrolling. What we get is that Grayson's sister certainly cannot say for sure that Grayson is using a weighted coin, but she has good reason to be suspicious. So Grayson's sister cannot say for sure that the coin is weighted. That Grayson is rigging the results. Right? But she has good reason to be suspicious. So this is pretty much what statistical inference is all about. 5 flips certainly isn't all the flips that coin will ever do. So we don't have complete evidence about all possible coin flips from our coin. We're just basing on a sample of 5 flips. We can't be 100% positive in our belief that the coin is weighted. There's a chance that it's not, but we can have use probability sort of to say the likelihood and make a guess that the coin is weighted. So this is one example of using statistical inference.